I'm going to record 93 too, because I'll do it right on here, okay?
Alright.
Yep. All right, so the idea is we're going to do some squeeze. I like sandwich better. Our book calls it sandwich theorem, because sandwich and squeeze mean the same thing, squeeze theorem. Okay. It says this: if h of x is less than or equal to f of x is less than or equal to g of x, for all x in an open interval, containing C if the limit as x goes to c of h of x equals the limit as x goes to c of g of x equals L. Okay, so all that's saying is, hey, the things that f is sandwiched between have a limit of L. They have the limit of the same thing. So what that means is, if that's true, the thing that's between them, which is f of x, is also going to have a limit of L. Okay, so, and the visual would, like, I kind of drew it, I'll draw it again if you want. Here's like h of x. Here's g of x. This is L right here. Then even if f of x is like undefined right at that point, it's going to squeeze it to that same limit as essentially what that's saying. Okay, so I'll let you finish writing that because I don't want to rush you. And then I'll talk about what 93 asks. So we did some of this when we did oscillating functions in chapter 4 in pre-calc, and you might not remember it. But what 93 basically says is, on our calculator, we're going to graph these two functions. And then we're going to graph this function. Because what they're saying is, what we learned before is, if there's a like kind of a function out in front, it oscillates between those two functions. And then we're going to use that to evaluate the limit. So let me find if I can find my calculator. Did I take it out yet today? Not yet, I did. So, what I would tell you is, which limit are we finding? The limit as x goes to 0. So there's the absolute value of x. I'll throw a negative out in front. that one. Okay. So that's what those graphs look like. Okay. And then I'm going to graph the sine x function is going to stay between those. By the way, can you guys tell me what the limits of both of those are as x goes to 0? 0. So if I know that sine is going to be between those two, what's going to be the limit of this function? Still 0. Okay. So I'll put it up there, but we kind of know, or hopefully are seeing what this is saying. There it goes. Okay. Are you kind of seeing the visual of that then? So the limit of that is 0. Okay. So I think you guys know how to factor difference of squares, right? Gotta pull up my formula. Like if I said factor x squared plus, or x squared minus 25, what would that factor into? So quiet. X minus there, we never talk about it in number 1. I think probably some algebra 2 teachers talk about it. I don't think Mr. Include calculus. But there is a formula for differences of cubes too. And actually there's a formula for sums of cubes. And there were some questions once in a while with limits where you can remove them. So I just want to put them in there so you've seen them before and then just give you an example. Difference of cubes can be factored into a linear and then some kind of trinomial. And the linear factor is always like whatever these are, you take the cubed root of this, which would be a, and the cubed root of this, which would be b. We're going to use a different number in a second. So it would be a minus b out in front. And then the trinomial is always going to be a squared. And then you multiply those two together. So plus ab and plus b squared. Okay. Let's do sum of cubes, and then there's 2 questions, and we'll just do one of them together. Now, here's the difference. We cannot do a sum of squares, like you can't do x squared plus 25 squared. You can factor a sum of cubes. The difference with the sum of cubes is out in front, first of all, instead of an a minus b, it's an a plus b. And then the inside is flipped around. This is a squared minus ab plus b squared. I'm just going to write this down so we have a title. Difference of cubes. This was a homework question, but it wasn't assigned because it's 47. So this would be an example of what I'm talking about. So the limit as x goes to 2 of x cubed minus 8 over x minus 2. Okay, do you guys see how it's a determinant form? Like this would give me a 0 if I put it on top over 0. Okay, so I can remove it. This is a difference of cubes, okay? So what's the cubed root of x cubed? X. What's the cubed root of 8? 2. So my a and b in this situation are x and 2. So out in front, I would write this as x minus 2. And then this goes to x squared plus, I multiply a and b together, so that would be 2 times x plus 2 squared, which is 4. Now, if you don't believe me, if you FOILed that out, you would get x cubed minus 8. Things would cancel. On the bottom, I get x minus 2. What can I do now? Now you could cancel the 2's, and plugging this in, I'd get 2 squared plus 2 times 2 plus 4, or, let's see, 4 plus 4 plus 4, or 12. I just thought I should show you that. I know we'll have to review it again if we end up seeing it, but if you see that and know in your head, oh gosh, I know there's a way you could factor it, probably you could work your way around it. It would be probably on a multiple choice section, okay, where you would be able to probably figure it out. But there is a way to factor differences in sums of cubes. So I wanted to touch on that. Okay. What do you want to